there are so many things, I think, in science especially, that warrant challenge, because we accept them, we believe them, but whether they're actually true or not is another issue. Once they're in the textbooks for a number of years, they become fact, a number of generations. And it's easy in the textbooks because, the publishers want to sell books. And if they present some alternative idea that the author prefers over the standard idea, the publisher may not publish it because they realize that universities are not going to purchase it for their students because it's too alternative. And you want the students to be able to pass various examinations. And if you teach them what you think is truth, but it's alternative, they're going to fail the exams, you see. And so the system is built in such a way as to discourage alternative views from being articulated, unfortunately. Many of them contain aluminum, particulate aluminum, which is, of course, highly hazardous to health. And there was a doctor there from Germany who does filtration of blood, to see what's in the blood, what's causing your various ailments. And he found two things that didn't surprise him, but one is glyphosate. I think you probably know about that. It's Roundup and, a weed killer. And in theory, it doesn't do anything to us, but it's one of the main things that they found in the blood when they filtered the blood. The other is aluminum. And, there's no reason why people should have high concentrations of aluminum. So apparently the aluminum in the chemtrails is somehow filtering down and into the water we drink, the food that we eat, and the air that we breathe. And this is destructive to health. So
the future is a concept. It doesn't exist. As the proverb says, tomorrow never comes. There is no such thing as tomorrow. There never will be, because time is always now.
Welcome to the Philosophical Minds Podcast, the podcast about the stuff we wonder about and other things.
We are here with Professor Gerald Pollack, a scientist, worldwide speaker, and author. His passion lies in exploring the depths of natural truths. He is a professor of bioengineering at the University of Washington, where he maintains an active laboratory. He has received numerous honors, including the Prigogine Medal for Thermodynamics, the University of Washington Annual Faculty Lecturer, the NIH Director's Transformative Research Award, and the first Emoto Peace Prize. He's founding editor-in-chief of the Multidisciplinary Research Journal Water, director of the Institute for Venture Science, and he is founder of the annual conference of the Physics, Chemistry, and Biology of Water. Also has somewhat of an electrical engineering background as well. He has award-winning books that include The Fourth Phase of Water and Cells, Gels, and the Engines of Life. Gerald, you are a true scientist, in my opinion. It appears you have an impeccable ability to adapt to new data and avoid getting caught up in the dogma. So to start off, tell us a little bit about your philosophy as a scientist, the mindset you maintain when going about your work, and your notion of scientific activism.
Oh my goodness. Okay. You've covered it all. How many hours do we have?
As many as you'd like.
No. Okay. Well, science is truth-seeking. And that's what science should be. But science is, the practice of science has somewhat deviated, in my opinion. You start by asking me philosophy, so I'll get right to it. I think that many people doing science are oriented toward filling in the gaps of what we already think we know. And some of those aspects of what we think we know, it may or may not be true. And so many scientists are oriented to doing exactly that, and we don't take that approach at all. We ask questions about fundamental laws of nature, and we ask whether they're indeed true, because if you have a foundation, if the foundation is not a secure foundation, then anything you build on that foundation will not be secure. It will be very complicated. It's kind of like when people thought that the sun was rotating around the Earth, and in order to explain that, we needed cycles and epicycles to describe their orbits. It became apparent that something had to be wrong with this. Everybody believed it until the time of Galileo. That belief system prevailed, and in fact, the church attempted to maintain that point of view, but Galileo pointed out that all they had to do was look in the microscope and or in the telescope, and they would see otherwise. But there was some reluctance to do it because the belief system, it was firmly established, and it was, and so that's the sort of thing I'm talking about. When a scientific concept becomes complicated, there's a good chance it's probably wrong because nature operates simply. So that's at the heart of our philosophy, that we're looking for simple explanations for phenomena that we see every day. I'll give you just one example. You see a cloud that's up in the sky, right? Cloud's made of water. This is something many people don't really think about. The cloud is made of water. If you take that glass of water from which you're drinking right now and you tip it slightly so that the water pours out, the water goes down, right? It doesn't stay up, but clouds stay up, and clouds are made of water. So how is it possible that something up there made of water is floating in the sky? So that's probably a question that you've never thought to ask. Most people have never thought to ask, but it's a question, it's an observation that demands, it cries out for interpretation. So this is the sort of thing that we would look at and try to find an explanation for some common phenomenon that is really not well understood, and people sort of ignore it. So that's just an example. Anyway, I don't want to blabber on and on about that, but truth-seeking at its very foundation is really what moves us, if that answers your question adequately.
Absolutely. Now I want to talk about something we mostly take for granted, water. This is something you've written a book about. We all know the basic solid, liquid, gas, hydrogen to oxygen, but apparently there's a lot more going on. And I'll let you kind of describe what that is, if you wouldn't mind.
Sure. 2 hydrogens, 1 oxygen. Slip of the tongue. Okay. But,
shows how educated I am.
Yeah. Well, yeah. So I guess it starts 100 years ago when some scientists were thinking, and there was one in particular, that the theory of 3 phases of water, solid, liquid, vapor, doesn't explain a whole set of observations. By now, they're called anomalies because they don't fit the paradigm. By now, there are 60 or 70. There's a famous website that lists a whole bunch of them, most of which are of interest to scientists, but not necessarily to many other people. But when you have a paradigm of, let's say, 3 phases of water that we all know about, but there are so many anomalies, the anomalies keep building up, then you have to begin asking yourself, is the underlying foundational theory correct, that really we have only 3 phases? And so 100 years ago, there was some discussion of the possibility of a 4th phase. Now, we identified a 4th phase in the laboratory with experimental evidence, but I want to emphasize that this is not a new idea. This is an idea that is more than 100 years old, that there must be a 4th phase. Now, that 4th phase is not trivial. It's not a sort of a trivial amount of water that you could see only in some special laboratory conditions. It's the water that fills your body. And so it's highly relevant. It's all over nature. It exists all around us. And it has the capacity to explain what's otherwise unexplainable. So this is kind of background. And what I want to emphasize is that although we now have, I think, clear evidence for the existence of this phase, and it's a really important phase, it's not a new idea. It's an idea that's been around for a while. Even one of my own personal heroes, the biochemist Albert Szent-Györgyi from Hungary, He won the Nobel Prize for discovering vitamin C, and he's considered by many to be the father of modern biochemistry. Besides discovering vitamin C, he studied muscle contraction, he studied water, and he has many famous pithy quotes. And one of them is, "Life is water dancing to the tune of solids." So he knew that water was centrally involved, and that the movements of water were centrally involved in basically all cellular mechanisms. And he was a hero of mine not only because of pithy statements like that, but because he tended to be right on things that he was talking about. So anyway, and then there was another one, Gilbert Ling, who by the time I met him, he's now 100 years old, by the way. He was born in 1919. And Gilbert had, by the time I met him, had written, I think, 5 books, and they mostly had to do with water inside the cell. And he argued that there's something that's different about the water inside the cell. It's not like water in a glass. In water in a glass, the molecules are moving around furiously at a gazillion times per second, and they're randomly oriented. But he said inside the cell it's different. It's not like that at all. He said the molecules are ordered in some way. They kind of stack upon one another, and that this is centrally important in features of the cell. The idea went against conventional thinking, and Gilbert was ridiculed by many people. But when I got hold of when I met him and started reading his books, which are really challenging to read, not only did I see that he had something that was really important, but also the students in my lab who looked at his book told me their response was, this guy is onto something extremely important. And I don't know if he's right in everything he says, but there's some parts of this that seem to be heading toward truth. So I got so interested in it that I actually switched fields. We had been doing studies of muscles and how muscles contract at the molecular level. One of the odd things about that is nobody ever considered that there's water inside the muscle. In fact, the muscle is 2/3 water. And so the concept that 2/3 of the muscle had nothing to do at all with the mechanism of contraction seemed a little bit odd to me. So the confluence of meeting Gilbert Ling and recognizing that there's something wrong with how people are thinking about muscle contraction led me to one of the books. It's called Cells, Gels, and the Engines of Life, and it was published 2001 with mixed reviews. Some loved it, thought that this was the central future of cell biology, and some hated it. Oh, this is just an extension of Gilbert Ling, who we all know is a crackpot. So be it. So anyway, that's how we got interested, and we found we knew from Gilbert Ling's ideas that if you have water and if the molecules are organized, as Gilbert Ling suggested and Albert St. Georgi and way 100 years ago, if this is really true, when you have organized water molecules like a crystal, sort of like ice, but not ice. And when this happens, as this crystal grows, it pushes out all extraneous solutes and such, which means if you have this water, it should be pure. And so we looked at a preparation where we had water and particles. We used little spheres, microspheres, and we saw that when that water was next to a gel or next to a hydrophilic water-loving surface, there was a region where all those particles were excluded. And we thought maybe, just maybe, this region is a region where the water molecules became organized. And so to make a long story short, we spent 5-10 years studying this, and we confirmed by at least by now 10 or 11 different methods that this water is different from ordinary water in a glass. It has distinctly different properties. And one property is that the molecules are organized inside of that. The second, it's not neutral, it's charged. And the region beyond this special kind of water has the opposite charge. So it's kind of like a battery where you've got negative charge in that. And by the way, we call this the exclusion zone because it excludes solutes. We call it fourth phase water because the water inside is not like ordinary water. So it has these really interesting properties, and I guess in terms of the existence of that water, as I alluded to earlier, it's all over the place. It's just that we haven't recognized it, and it's especially apparent inside your body because, as Gilbert Ling was talking about, although I think our concept is a bit different from Gilbert's, but this is what's filling your cells and filling your body. So that's a kind of capsule of what we're talking about, or at least of the discovery.
So with this exclusion zone water, or easy water, I think you referred to it
Right,
as,
easy.
is there actually a literal application with this two batteries?
When you say a literal application, you mean is there a practical application? Is that what you mean? Well, yeah. One thing is that it supplies much of the energy for your body. I guess you'd consider that to be practical or useful, and it's not something we think about where the energy comes from, but this water contains potential energy. As you say, it's a battery, and batteries contain energy, and that energy can power many things that happen inside your body. I can tell you more about that if you ask me. And in terms of the kind of practical that you're thinking of, I think, which is a technological application, absolutely. So we have a company that is developing some of this stuff. It's by some quirk. It's called Fourth Phase Incorporated, and we're working on several practical applications. The one you asked is about getting energy from the battery, and indeed, so we have a situation that we've confirmed in the laboratory that we can take a chamber that has a negatively charged EZ water, and next to it the positively charged water, and we put one electrode in the negatively charged EZ and one electrode in the positive, and we can connect it to, say, a light bulb and light the light bulb with it. And all of this comes from the water. But there's one step more that I haven't mentioned, that energy it's not just created mysteriously, it comes from somewhere, and we found that it's actually light that creates it. It's an incident light that builds this exclusion zone, and particularly infrared light that is beyond red in the infrared region. 3 micron wavelength is the most effective one, and so it's kind of like a recharging of the battery. So the light comes in, it builds the EZ, separates the charge, and from that separated charge you get electricity. So what we're doing is using water to convert the sun's energy, which 50% of which is infrared, converting that energy into electrical energy. It's like a solar cell, but it just involves water and light. So yes, practical applications. There are more, but I'm just responding to your particular question.
Amazing. And then in terms of, I think you mentioned it being important for muscle function, the exclusion zone. Do you think that that's something that would be beneficial as some kind of supplement?
Well, yes, indeed, and we're working on this. So it was actually an Italian group, not us, who discovered that you can take this EZ water and you can make out of it a solid at room temperature. So imagine a kind of water that at room temperature, not in the freezer, at room temperature is a solid. Okay, and we've now confirmed that result and duplicated it. And so you can, as a supplement, I could imagine, since this EZ water is good for health, we have experiments that demonstrate that. I could imagine a supplement built of this solid EZ water at room temperature. You swallow it, you get the EZ water, and that improves your health. I don't know if that's going to work. We've never tried it, but this is in the future. Right now it's a kind of dream, but it might happen in the future that this could be a supplement is kind of a universal health promoter, just like some agents that were discovered, for example, in Ayurvedic times thousands of years ago that are still used today. And people know that they're good for health, like turmeric, for example, like basil, which they call holy basil, and other substances that nobody understood why exactly, but we did experiments and we determined that at physiological concentrations, the concentrations that would exist inside your body, these build easy water. And you need easy water for function. If you don't have enough of it, you're basically dehydrated. And if you're dehydrated, your cells don't work well. So refilling your cells with easy water is good for health. And you could get it in a number of ways, one of which, in theory, is using this as a supplement, as you suggested. So that is in the future.
I'm curious, have you in your lab tested different types of, say, spring waters versus tap waters in terms of the density of the naturally occurring easy water?
We haven't, but other people, we haven't done it systematically, but we know that certain spring waters are full of easy water. And the way we test it is we put it into a machine called a spectrometer. And we know that, and what that does is it measures the absorption of light at different wavelengths. And we know that easy water absorbs light at the wavelength in the ultraviolet region of 270 nanometers. And so if we have a sample, if it shows absorption at 270 nanometers, we take that as an expression of the presence of easy water. And if the absorption is higher, if you get a higher peak of absorption, you got more of it. And we've tested a few spring waters, and many of them show a really strong absorption peak. Other groups have been studying this as well, and I've seen examples of extraordinarily high peaks at 270 nanometers from spring water.
Okay. So my next question is going to be, what are some of the other practical applications to this?
Thanks for asking. One of them is filtration. And again, we have a successful model in the laboratory, but trying to convert that successful model into something that's practical with a large throughput is a challenge. We're working on it. So filtration occurs because the easy water is free of contaminants, pollutants, solids. It just expels them just the same way that when water freezes into ice, it pushes out everything else in order to get a pure crystal of ice. And so the easy does the same. And so what we've devised is a method by which we can extract the easy water, good for health, side benefit, and also it's free of these contaminants. And it works, but as I said, there are technical limitations, and it's basically limited by investment. People who there are people who are excited about this, and we need to do a better job of securing investment, because without the investment, you can't hire the people to do the necessary technical development. And so we're looking for more investment. And one of the things that really excites us about filtration is not just separating all the junk that we have in our water these days from all pollutants that you all know about, but also salt. Because if you can take ocean water and get rid of the salt in a practical way, then you can get drinking water directly from the ocean. Of course, this is possible now and done all over the place using reverse osmosis. But the problem with reverse osmosis is that it's costly energy-wise. You have to put a lot of energy in to build up pressure, to force the water through the pores of the filters, et cetera, et cetera. And, in some places, this is used almost exclusively. I was visiting Saudi Arabia several years ago, and I got a tour, and they showed me their desalination plants with reverse osmosis. And I guess they've got the wherewithal to pay for it. But, in arid areas where the water is needed and the money is not so available, it would be nice to have a method that is is simple and effective and not costly to run. And so in this same strategy that I was describing to you in filtration, we think we can filter out the salt. And we have some experiments that look promising, but right now the result is not consistent. So we're working on this development. And the advantage is that, first of all, there's no physical filter that you have to clean or replace or whatever, and that tends to be a hassle, a costly hassle. And the second is it costs no energy except the energy from the sun to separate out easy water from ordinary water. And so this is very exciting for us, and it's dependent on investment to develop the resources, to develop it to the point where it becomes practical.
It's amazing. And so back to kind of like from a biological standpoint, how does this correlate with like mitochondrial health, that exclusion zone?
Well, we're not sure. We've never directly studied mitochondria, but if you know the anatomy of the mitochondrium, it's got these many membranes inside this package, and these membranes are just the kind of membranes that we would expect buildup of easy water next to. So we think the reason for the electrical potentials inside the mitochondria could well be due to the development of easy water, which has a net negative charge inside the mitochondria. And that's the kind of energy. We all think of ATP as being the energy source for the cell. And that may well be the case, and probably is the case, although there are some studies that raise question about this that many people are not aware of. But we're pretty confident that this charge separation that occurs with easy water, that probably the mitochondria is filled with easy water, and that gives rise to the electrical potential, which contains energy. So the bottom line is that it may be that the energy that we get comes not only from ATP, from the food we get, but also from the light, the infrared light or infrared energy that comes not only from outside, but also from inside, from our metabolism, which generates heat, which is equivalent to infrared energy, which builds EZ, which may occur hugely inside the mitochondria. So this is right now hypothesis. We've not tested this, but I think it's likely.
Do you have any questions you want to ask about?
I had a question about, I always observe my environment and try to put things together and, figure things out. And there's things that people do, and I think every day that they don't really think much about. And just one thing that, as you're talking about this, I think of is back when, they had the rabbit ear antennas for televisions before cable and all of this stuff.
I remember.
Yeah. When, you walk past a television that has those antennas and you touch it, it changes the static on the screen. And I've always asked the question from the time I was a little kid, okay, what causes that static electricity to change by our bodies simply being present? Because obviously there's a lot more electricity going on in our bodies than we realize. Do you think that this potentially could be related to that?
Could be. Did you say related to that? Is that what you
Right.
said?
Or
yeah. So
that could be the cause.
yeah. So we're a complex of electricity. Every cell inside your body is negatively charged, and people learn, like medical students learn, that this has something to do with the channels and pumps in the cell membrane, but I think not, for reasons that I don't need to go into right now. But I think it's illogical and contrary to evidence, although virtually every biologist learns this. But I think it's wrong. I think the reason the cell is negatively charged is that the water, the EZ water that fills the cell itself, is negatively charged. So you basically got a bag of negatively charged stuff, and of course it's going to be negative. So when you add up all the cells in your body, you got a lot of negativity, so to speak, pardon, negativity. And your body, your whole body is net negative. You're not neutral, you're negative. And the contrast that when you touch the antenna, it's a lot of negative charge that is being connected to the antenna. Now, if you're not touching the antenna, the antenna is exposed to the atmosphere, and the atmosphere, I'm not sure if you're aware, I wasn't aware until fairly recently, the atmosphere has net positive charge. I learned, to my surprise, but the evidence is clear, that the Earth is negatively charged and the atmosphere is positively charged. It's interesting. This also has a kind of separation of charge. So in step one is the antenna is exposed to positive charge from the atmosphere. Step two, it's connected to a big negative charge from your body. So it's going to change. The external conditions are completely revised, and if that happens, then I would suppose that the image itself is going to be completely revised. So it means that what's being received now is a relatively static negative electrical potential when you grab the antenna, compared to what it's usually exposed to, which is positive charge and also electromagnetic energy coming through this positive charge and reaching the antenna. So it doesn't surprise me that what happens is what you described. A negative charge of the Earth is extremely important. I'll just mention, since I did mention early on about the clouds, and I think the reason those clouds are floating in the air is that we know they have a net negative charge, and the Earth is also negatively charged. And so they repel each other. And the highest clouds are the ones with the most negative charge, and the lower ones have less negative charge. So I think that's the correct explanation, although, I might be
on that note, anytime I can, get anybody to back up the legitimacy, so to speak, of earthing, I don't know if you're familiar. From your perspective, scientific perspective, do you see benefit of bare feet to the ground, kind of?
Well, I've read the papers, and I know the people who have done the experiments, and various family members earth or ground themselves, and the research shows that it has widely beneficial effects on so many aspects of their life, from better sleeping to generally overall better health. And all they need to do is take off their socks and shoes and walk barefoot, not on the wooden floor, but on the earth, something that's connected to the earth. My son actually does this, the fellow who illustrated my latest book, The Fourth Phase of Water, in which a lot of these things are described. The book has become very popular. He does it. He's sitting at the computer screen, and he has an aluminum plate. He puts his feet without socks on the aluminum plate, and the plate is connected to an iron rod that's driven deeply into the earth. So he's really solidly connected. And then there's the story of George Washington. I don't know if you heard the story, but George Washington would travel with his personal physician because I guess he was either paranoid about getting ill, or maybe you do that instead of having bodyguards at that time, you have physicians traveling with you. So one day he got sick, and his physician looked at him and said, "Okay, George, here's what you need to do. Just hug a tree." So the story is he hugged the tree, and then he quickly got better. So why is that? Well, the tree is a lot like us. It's got cells. The cells have negative charge. The tree is negatively charged. And by connecting himself to the negatively charged tree, he was able to infuse negative charge into his body. And we know that when you infuse negative charge into your body, that builds easy water. So easy is negatively charged. You put negative charge in, and it builds more of that stuff. And that's what we found in the laboratory. So I think that could be the reason why George Washington preserved his health for some time by hugging a tree. And I guess that is sort of equivalent to walking barefoot on the beach. It seems to have positive effects. And we think the effects are mediated by buildup of easy water.
Is there a difference between the benefits with the type of matter that it is? So for instance, if you're dealing with a wooden tree, right, the tree is actually physically rooted into the ground, absorbing minerals through the roots, versus a wooden floor that's not, anchored into the ground in any way, but it, usually has that underlayment under it, versus sand, that's on the beach. Have you guys studied that at all, or looked?
Well, we haven't studied it, but I think it follows from basic physics because you need a conductor. If you think of the Earth as being just a ball filled with negative charges, and if you connect yourself electrically to that, you'll absorb some of those charges. However, if you have a floor, so it insulates you from the Earth, and so you don't have the benefit of the ability to absorb those negative charges or get rid of your positive charges. Either one, they're more or less equivalent. So that doesn't work. The best place, I guess, is if you walk on wet sand, because of this, barefoot, because the sand is wet. It's a very good conductor, and you're then amply connected to the negatively charged Earth. And that's why when people walk on the beach for a half hour, they feel good afterward. I think this is the reason. Also, I should mention, I guess you guys live in Arizona, is it? So you don't have saunas there, or maybe you do, but in Seattle. Well, I've been to the real thing in Finland and also in Russia, where they do that all the time. They kind of need, and usually you go in and you come out, you feel better, you feel good, you feel more energized. Your muscle pains have disappeared and such. And as far as I know, nobody has really figured out why this is so beneficial, but I think I understand the possibility as to why it is, and that is it's heat, whether it's dry heat or moist heat, doesn't matter. The heat is equivalent to infrared energy, and you absorb that infrared energy throughout your body, and that energy is exactly what we found builds easy water. See, so it means if you're building easy water, which is the natural state in every cell, if any cell is deficient in easy water, and therefore pathological or non-functioning or painful, could be in your brain, or could be in your muscle, or whatever, the buildup of easy water caused by or created by this energy input is going to make you feel better. So if your brain and your body are tired, it's the end of a long day, all you want to do is go to sleep. Instead, you go into the sauna and you come out feeling like you just woke up from 8 hours sleep. I had that experience myself. And if you have a muscle that's cramped, infrared energy can build easy water and return that muscle back to its relaxed situation instead of its cramped situation. So I think this is one of the straightforward and simple benefits of having a sauna. Infrared energy builds easy in your cells, you feel better. It's simple.
I think additionally, I heard a mention of it releasing something called heat shock proteins. I'm not exactly sure the benefits of that, but that's something I've heard people reference, like Dr. Rhonda Patrick in particular.
I don't deny that many of these things happen. I'm just suggesting that there's a straightforward, simple interpretation which may supplement or even replace some of these theories that exist right now.
Absolutely.
Well, and what you're saying makes me think of, we have reptiles, and I'm fascinated with exotic animals because the way that animals take in water and basic necessities, you can tell a lot from that. And specifically with our iguanas, they have to have a heat source and they have to have water. And we even had an iguana that, got kind of an infection on the shoulder, and instead of taking him to the vet, I gave him a warm water bath, and, just up to his belly. And within a week, it's almost completely healed.
Good
so,
yeah,
it's really interesting.
Yeah, the water is absolutely central to everything we do. It's not, you won't find it in the textbooks because, well.
That's a whole other, it's one perspective. I talk to my husband about this a lot. For me, I just noticed a huge difference when I started taking my college courses in the way that information's presented. We were encouraged to look at both sides versus in the elementary to high school system, it's really one point of view, and the literature that you're reading and the material, it's skewed one way, but they don't really tell you that until, you go on and you go, oh, this might not be valid research, or there might be an opposing view that, answers the question a little bit more.
Well, I mean, that's not been my experience. My experience is that that's pervasive through university education, that one story is presented, and it may give lip service to alternative views, but
oh, wow,
they really want to teach it to you. It may be because you're an attorney, you went to law school, and I guess the essence is two different points of view that you need to consider, and maybe you're extrapolating from that, I wonder. I only wish that university courses were presented that way. Here's the prevailing point of view, and here's another point of view, and here's the evidence for this, and here's the evidence for that. Tell us what you think, whether you, if it were that way. But it puts a real burden on the professors, because they have to really understand both points of view, and otherwise they feel insecure standing up there in front of the classroom, and that's a real challenge. And that's why, in my experience, very few professors are teaching, here's the textbook view, and here's another view that you might want to consider.
Wow.
Yeah.
I studied at Leicester University, which is in England. It's about 3 hours north of London. And I did a semester there, and there it was very different. Even for my college courses at ASU, that's where I went here. They gave us basically a book list, and on that list, we had 30 to 35 books that were listed, and we had to select opposing viewpoints. So they would have, these books argue this point, and these books argue this point. So it was usually opposing views. We had to select off of those lists the books that we wanted to read for the course, and then we had our final written assignment. And most of the lectures were an open dialogue where we would discuss openly our views and what we had read, and really challenge each other's ideas. And it was amazing.
Wonderful.
I've done that a couple of times here, but only select professors.
It's pretty rare,
yeah.
I think, and maybe, yeah. And I think your experience bears that out, because it's not the usual course.
Yeah, right.
Work, because that's a great example. There are so many things, I think, in science especially, that warrant challenge, because we accept them, we believe them, but whether they're actually true or not is another issue. Once they're in the textbooks for a number of years, they become fact, a number of generations. And it's easy in the textbooks, because, the publishers want to sell books. And if they present some alternative idea that the author prefers over the standard idea, the publisher may not publish it, because they realize that universities are not going to purchase it for their students because it's too alternative. And you want the students to be able to pass various examinations. And if you teach them what you think is truth, but it's alternative, they're going to fail the exams, you see. And so the system is built in such a way as to discourage alternative views from being articulated, unfortunately. And I'm sad about that, because there are so many things in science that are unclear, unknown, and areas where we think we know truth, or at least that's what the textbooks say, but there's obvious evidence against it. And how wonderful it would be to actually promote discourse, two different points of view, and here's one side, the other side, you listen and you take your choice. But that happens rarely. I'm glad it happened in your experience. That's wonderful.
I consider myself fortunate.
Yep. Good for you.
Yeah.
Before it's too late, something I'm dying to ask you: do you have some kind of flying saucer in your laboratory?
Yes, we do. How did you know that?
I want to know everything about this. I listened to a recent interview and a podcast that you did with Greg Carlwood, I believe.
Oh, okay.
Yeah.
Did I mention it? Yeah, we have. And I'll tell you what it is. You start, and this is not unique to us, I must say. And we don't call it flying saucer, but
okay. I don't know what to call it.
No, it's okay. It doesn't have the shape of a saucer. However, I'd preface it by saying there's a book it's called, let's see, I can't remember the name of the author offhand. It's called The Secret of Anti-Gravitation or something like this. And it's written by a physicist. Right offhand I can't. And he discusses essentially what you'd call flying saucers, machines that levitate, basically, for over a period of 100 years, different examples of such, and is well documented. And even the government had been working on it. So here's what we have in the lab, and it's really no different from what you can find on the internet. Hobbyists are doing this. And it consists of very lightweight material, like balsa wood, for example. There could be other materials, shaped into, for example, barrel shape. That's one design. And wound around the top of the barrel is one wire on the outside, tightly. It's stuck to that framework. And then down below is another electrode, also tightly secured to that framework. That's all. That's it. And you connect these two wires loosely with a wire that's, this thing is going to rise up, and so you want a flexible wire to a power supply. You turn on the power, 10,000 volts, and it's like magic. This thing starts rising up, and it rises, and it stays up. It kind of bounces around a little bit, but basically it levitates. And then you turn it off, and the thing comes crashing right down. So
is this what's called like electromagnetic gravitics or something to that?
Well, anti-gravitic, I guess, because somehow it's against gravity. And as I said, you can find it on the internet, and it used to be a genuine academic pursuit. In fact, it was pursued apparently by the military of maybe various countries, and then it went dark, and it was left to hobbyists who would do this for fun. And it used to be that you could find a dozen different expositions of this, different shapes and different results on the internet. And now there are only a few that you can find. I'm not sure why. Maybe people have become less interested, but it's a device that works pretty much every time, and there's no moving parts or anything. Just an electrical potential difference is enough to raise this thing up. So it's pretty interesting.
Yeah. And at the point it's at now, is it large enough to hold a pilot or hold a person?
No. This is, at least in our laboratory, this is just a simple demonstration that it can work. We have no interest in developing this thing, which, as I said, a whole lot of people know about it and have experimented with it. We're not intending to develop this into any kind of commercial, but that book I mentioned does describe applications of this, including by a guy named Victor Schauberger, who is a hero. You know this name.
Okay. In the water as well, I believe.
Yeah, Austrian. Yeah, he was Austrian, and he was captured, if you will, by the Nazis when they came and took over Austria, and he was given a choice of either being executed or working with the Nazis. And so he developed some of these anti-gravitic devices, but at the end of the war, a lot of the stuff was destroyed or maybe taken over by various interested parties who were maybe connected with some governments. I don't know. The story is a little bit vague. But anyway, there's a lot of stuff along these lines you can read, particularly in that interesting book I mentioned.
It's fascinating. So with the Institute of Venture Science, I know this is kind of about challenging prevailing paradigms in the mainstream thought. I don't know if you go here, but there's something I've been discussing with various electrical engineers or physics-minded individuals. And I don't know if you have any insight into this, but the big one is Einstein's theory of relativity. Now, I'm not exactly sure if it's general or special relativity or both, but there's a large number of intelligent folks out there that take issue with the theory. I find that most of the criticism is largely in the realm of guys that are into like ether physics. And at this point, I don't know that I'm educated enough to conclude anything, but it sounds like they're making some good points. So I don't know, I'm curious as to your thoughts on Einstein's theory of relativity.
Well, I'm no expert on that, but I do know that there are various groups. There's one in particular. Let's see, what's the name of this organization? It's the first word is Chappelle, CHAPELLE, group or institute or whatever. And that institute was founded years ago and still exists right now. And the group was founded because there were many people who challenged various Einstein's relativity ideas. So they got together in a common forum, and this has persisted over the years, and it's expanded to other areas of science where the people in this organization take a dim view of the evidence and are looking into other interpretations of observations. So I mean, as far as I know, I have no distinct opinion on that particular subject because I don't have enough expertise to comment. But I do know there are many people out there who are challenging some of these generally accepted views.
Right.
It's not so simple to understand that stuff, and if you're not well trained in the foundations of physics, it's a real challenge. But those who are well trained, most of them accept it as truth, the ground truth, but others are challenging it. So always helpful to challenge. We get to the truth that way.
Now, I like that you kind of answered these questions that often a lot of times kids would ask, like what keeps the clouds up in the sky, different stuff like that. So I was wondering if you'd mind if I could just ask you a few. What makes the Earth spin?
Please see my next book.
We have had conversations about this, and we each have our own theories, on different stuff. So
I'm curious. Well, the more or less accepted view is that the Earth got a kick when it was born, and because it has a lot of inertia, it just keeps going. But usually all systems wind down, and even if it has a lot of inertia, there are definitely losses, like, for example, the tides, the frictional loss of water, passing layers of water, passing over other layers, and lightning and such. And so the question is, if it has a lot of inertia and you could keep it going, you could probably maybe think about doing it for a year or 2 years or 5 years, but, a million years, a billion years, 5 billion years, it keeps going. It's really difficult to envision. And there's also evidence that the speed of rotation has fluctuations to it. So in other words, if it has fluctuations, it slows down and speeds up, not by a lot, but you don't expect any speed up at all if there's no energy coming into the system. So if you take that observation, it must mean that the Earth is receiving energy in some way all the time. Otherwise, you can't get acceleration, even if it's a little bit of acceleration. And so I think that's probably not the right answer. I think there's energy that's coming in, and this energy is somehow converted into the spinning of the Earth. And so I guess maybe I should leave my comment, stop my comment there, because in order to explain how I think the Earth is turning, I need several steps. They're not complicated steps, but difficult to do it. So please, I don't know what the name of the book is going to be, but I'm hoping that within the next 6 or 8 months, the book will be out. It's not only about the subject. It deals with other issues, like if it rains, how come the whole cloud doesn't come down and hit you on the head? What's the real nature of gravitation? What causes it? How do birds fly? Your response, if I ask you about that, will probably be, oh, they flap their wings, right? I guess, maybe I'm wrong, but some birds don't flap their wings very much, or not at all. Right. I can see that outside my house where I am right now, there's an eagle's nest, and I can see the eagles coming out every day, and they just glide. And as they glide without flapping, they sometimes go down, sometimes they're level, sometimes they go up, and they go in every direction, with the wind, against the wind, and they don't flap their wings, or rarely flap their wings, but they can do it. So something else is involved. That's also in the book, what makes for weather. We don't really understand. And the atmospheric scientists don't, one of them admitted to me, the two things they really don't understand are evaporation and cloud formation. Mm-hmm. See, and if you don't understand that, there's no way to understand weather, because that's what weather is all about. So there are a few chapters about what makes weather. And there are a few other subjects in there. How you can sail almost directly into the wind on a sailboat. You guys sail?
No. Arizona, there's not. I mean, we have man-made lakes here, but they're not my favorite to go visit. So.
Yeah. Okay. So yeah. So most sailboats, every sailboat can go with the wind. That's easy because the wind is pushing on the sail. And most sailboats can go up to about 45 degrees, racing boats 30 degrees off the wind. But ice boats, same as a sailboat, but they skid on ice, so the friction is reduced. They can go almost directly into the wind. So you have a boat, the wind is blowing this way, and the boat is going this way directly, almost directly into the wind. How could that be? I mean, how do you explain that? So anyway, I don't want to go into great detail, but the book will hopefully come out, because it's almost done in the next 6 months.
Yeah, I mean, to me, there are a lot of unanswered questions, with the Earth's rotation and seasons and everything, because a lot of stuff that isn't answered is, for instance, with this large body of water that is the ocean, that's approximately at least 70%, of what makes up this Earth. You think with moving at that high of a speed consistently, there would be a lot more movement in the ocean aside from just the waves that kind of wash up on the shore. So to me, there's a lot of things like that I noticed, that the theories that are out there, it doesn't really account for all of that. So I'll be very
No, it doesn't. That is a good point. There are many things to be studied. On that particular issue, though, the Earth is spinning, but it's not that the atmosphere is stagnant, because if the atmosphere were stagnant and the Earth were spinning, we'd feel a huge wind all the time, something like the speed of twice the speed of a jet plane. So the atmosphere is moving along with the Earth, at least at the surface of the Earth, because we don't feel that wind. We feel some wind occasionally, but nothing like what we would expect. And that's important. And there are also winds, consistent winds, like the trade winds, which run around the equator near the surface of the Earth, that run from east to west, and that's how Columbus made it to the New World. But then higher up is the jet stream, which runs from west to east, and that's why you can make it from New York to Paris more quickly than you can go from Paris to New York. So why do we have these winds? What's the nature? This is addressed in the book, and I think these winds, just to give a hint, if it's of interest to anyone, I think these winds are part of what is pushing on the Earth and making it spin. But the exact arguments, please wait for the book. I think there's something. Yeah, go ahead.
On that note of weather, I'm curious your thoughts of something called stratospheric aerosol ejection. That's where they're releasing, I believe, strontium, aluminum, and barium nanoparticulates into the air to make clouds to block sun for global warming, supposedly. I'm curious your thought on that and how that relates to water quality, since you're big into the water and all that.
Well, let me address it in terms of health quality, because I just attended a symposium in Germany dealing with environmental effects on health. And, aluminum you're talking about chemtrails, I think, and many of them contain aluminum, particulate aluminum, which is, of course, highly hazardous to health. And there was a doctor there from Germany who does filtration of blood to see what's in the blood, what's causing your various ailments. And he found two things that didn't surprise him, but one is glyphosate. I think you probably know about that. It's in Roundup and, a weed killer. And in theory, it doesn't do anything to us, but it's one of the main things that they found in the blood when they filtered the blood. And the other is aluminum. And, there's no reason why people should have high concentrations of aluminum. So apparently these the aluminum in the chemtrails is somehow filtering down and into the water we drink, the food that we eat, and the air that we breathe. And this is destructive to health. So this is a big deal. So, I mean, we don't study this, but you asked for my opinion, and I've been convinced by the evidence that I saw that this is a real problem that we have.
So I want to ask you, is there any applications that we haven't covered in terms of the exclusion zone water that you would like to talk about?
Yeah, well, drinking water is another issue. I get either phone calls or emails practically daily. What kind of water, which water should I drink? And the answer is, I don't know, because probably the best way to find out is to do clinical tests. You take cancer patients, for example, and one group gets water A and one gets group B, and you see how they fare. Or people with any kind of illness or ailment, or healthy people even, see if they get even more robust depending on what they drink. And there's a lot that goes around on this stuff, but what the information that we have is that almost certainly, if you drink water that contains EZ water, this is going to be good for health. And we're working on getting more evidence for that. But there are people now who have products, and some of these people say, "Oh, this water is structured water, or it's fourth phase water, or EZ water," and we don't check them or study them or have any interest in monitoring what they say. But I think there's a sense that is developing that if you're able to drink EZ water, it should be good for your health. And it makes sense to me because in many cases, when you're pathological, there's a diminution in the amount of EZ water in your cells. So, for example, if you have a cancer cell, and you investigate the electrical potential of the cancer cells, which has been done, instead of having a lot of negative electrical potential, which all of our healthy cells do, the cancer cells have only a little bit. Instead of like minus 80 millivolts in your cells, you're healthy. Cancer cells might have minus 20 or something. And our interpretation is it means it has less EZ water, because if the charge is coming from the EZ water and you have less charge, you probably have less EZ water. And so if you're able to drink the EZ water, doesn't matter what pathology we're talking about, because of the ones that were studied, it's always the case that there's less negative electrical potential in the pathological cells. And so one route to restoring normalcy is to create more EZ water to restore what's needed for the proteins to function inside the cell. And so we think that drinking EZ water is one route to achieving this. You can also do it through juicing, taking plants and squeezing them and drinking the juice from the plants. And there are many shall we say, alternative practitioners, naturopaths, integrative doctors and such who advise doing that. And they report that their patients do really well. They drink this for a few months and the patients feel better. They've lost weight also, which they're happy about, but they also feel more robust. And so by doing that, what you're really doing is you're drinking the water from inside the cells of the plants. Freshly grown leaves, lots of EZ water, and you're drinking that EZ water. And some people think it can't work because the stomach is acidic, and when the water passes through the acid stomach, it neutralizes all of this EZ water. But it's a quantitative argument, so the pH of the stomach might be 3 or 4. It's acidic, but there's only a small amount of acid. See, and so if you drink a substantial amount of water, and that's going to mix with a small amount of acid, it's not going to have a major effect. That's the counter argument. And so we think, and our company is working on this as well, that to develop a kind of water that is really good for health. There are some out there, and every one of them claims that they're good for health, and they might be. I'm not sure. But that's another application. I think that's really important because everybody wants to be healthy. And
Right.
a lot of people want to know, which water should I drink? Is the stuff with the chlorine and fluoride in it good for me, or is it not good for me? Is there another kind of water that might be better and cheap also? So, yeah.
And I do have one final question on the absorption of water. So could you talk about, taking water in through drinking? Have you seen any benefit or studied any benefit of water by immersing yourself? You had kind of talked about it with, going into a sauna. If you were to take this easy water in large quantities and, for instance, fill up a tub and have it heated, do you think that may potentially have some similar benefits or not as good because the delivery is not, as efficient?
Well, I don't know. Having my naturopath's friends tell me about bathing in the bathtub with Epsom salts, I guess that's magnesium sulfate mostly, and it has a beneficial effect. So, your body, through the skin, definitely things can pass through. It's not an insulator, completely impervious to everything. And so these salts seem to have a positive effect. Also, what makes me think, I think of mud baths. So in Japan, it's very common for people, they have mud baths where people immerse themselves, and in theory, it improves your health. And the same thing with mineral baths all over Europe, especially in, for example, Bulgaria. These mineral baths are said to be good for health, and they've been used for eons, probably millennia. So yes, I think, I don't know about direct evidence because it's not something that I've reviewed recently, but there's a lot of lore and experience that suggests that bathing yourself in the right medium could be good for health. So I think it's a productive course, absolutely.
So, favorite thinker, scientist, philosopher, dead or alive?
You're asking me who
Yeah.
are my favorites? Oh my goodness.
Tough question.
Well, tough question. Well, Albert St. Georgi, who I mentioned, it's spelled SZENT hyphen GYORGYI. He's definitely one of my favorites. And one of the reasons, I mean, he died about 30 years ago. He was an exceptional thinker who had fresh ideas on so many subjects. And the ones I studied, I think he's right on. So it turns out that besides discovering vitamin C, he studied muscles. And I said earlier, I studied muscles. And over the years, I developed my own ideas about how I think muscle contracts, differently from what you read in the textbook, completely differently. And only 4 or 5 years ago, I came upon a book written by Albert St. Georgi, and I couldn't believe what I was reading. What he knew and said 50 or 60 years ago about muscle contraction is almost identical to what I wrote about in my 1990 book about how muscles contract. And I didn't know that St. Georgi had come up 50 years or whatever earlier with almost identical idea. And so naturally, since I think our ideas have some merit, I admire this guy hugely, because even without the benefit of modern day experiments and understanding, he came up with what I believe is the right idea. So he's definitely one of my heroes. I'll tell you another one who was one of my heroes. Rupert Sheldrake. Do you know that, Rupert?
That's morphogenic resonance.
Yeah, right. Yeah, and so I regard him as sort of the dean of alternative science, if you will, because what I admire is and we've become friends, and I admire his approach to studying things that fall between the cracks of modern science. It requires courage to do that, because you have many people who say, oh, these guys are he's a crackpot, whatever. Yet he persists, and his experiments are so interesting. And he's faced challenges. I think maybe you know that he gave a TED talk, and it was pulled by the TED organization because it was too I don't know, radical. And so, of course, what happened is everybody became interested. And more people watched his TED Talk, which was put up on YouTube, than on the TED network than he would have had. So he's another. And finally, I got to mention one who you will regard as extremely controversial, and that is Peter Duesberg. Probably you never heard of him?
Never heard of him.
No, okay. So Peter Duesberg, and I'm sorry this will come across as extremely controversial, on the borderline of being crazy or nutty, but Peter Duesberg is one of the founders of modern molecular biology, and he's at Berkeley. And when AIDS first was identified, what was it, 40, 50 years ago, something like that, Peter Duesberg, being in the field, knowing about retroviruses, being a guy who was for sure on his way to a Nobel Prize, because he had a laboratory of 50 people or so, was well funded. And he said when the idea that AIDS was caused by a retrovirus, he said it's impossible. And he wrote a book on it, and he explained why it was impossible. And the book is absolutely fascinating reading. It was called Inventing the AIDS Virus. And it's a really powerful read that anybody, even without scientific background, can read. He said he doesn't know what the cause is, but it's not retrovirus. Of course, he became pardon me?
Sorry.
Yeah, no. He became controversial, obviously, with all the pharmaceutical companies trying to drive him out of business, because they make a lot of money from the antiretrovirals, and all they need is someone like Duesberg. So right now, Duesberg has become rather unknown. His ideas are not widely discussed, but there are actually multiple books that come to the same conclusion, that AIDS is not the result of a retrovirus. And I recommend to anybody who has an interest in science to read his book and then come to your own conclusions. He may be dead wrong, but I tell you that his arguments are cogent and clear. And the reason he's a hero of mine is not because he might be right, but he might be wrong, but that the guy had the courage to say what he thought, and despite the obvious forces running against him. So Peter is one of my heroes. He suffered hugely because it's been almost impossible for him to get funding in any way, and it was because of his attempt to follow what he thought was truth. You see, you do that, it gets you into trouble. And it's happened to almost every scientist I know who has challenged the establishment. The Galileo story is very famous, but it's not just Galileo. It's true in our modern times too, that people who challenge the establishment almost always run into trouble. So so these people, for me, these kinds of people are heroes. They might be right, they might be wrong, but wonderful for them to challenge the status quo in scientific ways. So, highly recommended book. So if that answers your question, yeah.
I think that's an interesting take, because I think that as people tend to, get older in years because of history or experience, I think by human nature that we are creatures of, what's comfortable and what is familiar. And the more that you take someone into an unfamiliar space, there's more uncertainty, and then that's related to fear. I studied in social sciences and just the connection between those things. And then you have, this field of science where instead of pushing against what we've been, taught from a very young age and kind of challenging what the quote unquote norm is, it's easier to fall in line and to kind of just set into the framework that's already there. So I too have a lot of respect for people who step outside of that framework, because otherwise we would not figure out a lot of the things that we, figure out and advance further. So I think that's...
it's particularly difficult for scientists, because if you're a scientist in the mainstream and someone comes along and says, hey, all you've been thinking is dead wrong. It's not even close. It's a non-starter. We don't want our toes to be stepped on. And I think this is one of the reasons why we've seen so few genuine scientific revolutions in the past decades. It's really hard to name them. I'm talking not about technological revolutions, there are many of them. My laptop computer and your iPhone and et cetera. I don't have one. I stay away from the electromagnetic radiation. And this is the reason why there have been so few scientific revolutions, because the organizations that are designed to fund science, and we all need money in order to do our science, they're set up in such a way that the people who are doing the reviewing are the people who would be under challenge themselves, the experts in the various fields. So, if the world is thinking that the Earth is flat and you come up with some evidence that the Earth might be round and you submit your application for funding, you're not going to get your money, you see. And so any scientist who's canny enough to realize what the political or sociological situation is will keep his revolutionary or her revolution ideas to themselves, right? Because they're not going to get any money, they'll just get a reputation. But those people who are willing to challenge, those are my heroes. And let me just tell you, you mentioned Institute for Venture Science, and this is designed to circumvent that problem. We, at this institute, what we're doing is identifying those ideas, or the people with the ideas who challenge convention. They say, no, the conventional idea is a non-starter. It doesn't explain this, doesn't explain that. Here's a better idea. And we've already collected more than 200 of these ideas, narrowed it down to a group of 15, invited full proposals, identified 5 that we would like to fund. And these are ideas which, if proven to be valid, will turn the Earth upside down, will be revolutionary ideas. And we're looking for people, this would be privately funded, because as you can imagine, the government, no government that I know of, is willing to fund revolutionary ideas. It just doesn't happen. Governments don't work that way, although I was naive enough to think that it might until I learned. So private donations, and we're now looking for people who have done well and who would like to return something to civilization in a way that's really constructive and that will do something really meaningful. And we think scientific revolutions will do exactly that, because scientific revolutions always produce practical outcomes and practical dividends that can solve problems. And the Earth is full of problems these days, and we need to solve them. And one way of doing that is the political way, and the other way is the scientific way, where new, completely unforeseen discoveries may lead to technologies that we never would have dreamed of that could help solve our problems. So I encourage anybody who has interest, you can get to me through the URL www.iv, as in intravenous, ivscience.org, not .com, but .org, ivscience.org. Love to hear from you.
And then how could other people find out more about your work with the 4th phase of water and anything else you're working out? Where would you point them?
It's our lab website, and unfortunately I don't have the URL right with me, but if you Google under Gerald Pollack, University of Washington, you'll find it easily.
Awesome.
Yeah.
Well, thank you so much for your time. This was an amazing conversation, and I really appreciate you taking the time today.
Well, thank you, guys. I really appreciate your interesting questions and the opportunity to discuss this. It's my favorite topic.
Of course.